Hi, this is Joel from Visual Components, and I'll introduce you to the Python 3 API in this tutorial.
When following any tutorial, check the lesson in the Visual Components Academy, and if the Download Files option appears, you can download the example files.
To demonstrate the API, let's use a sensor component. We have a conveyor line, and let's add some logic to our smart sensor component. As we can notice, the pallets travel through the sensor, and if we open the signals tool, we will see that the sensor gets triggered every time the pallet is at the sensor location. When the smart sensor component is selected, I can see its component graph and see that it has a Python 3 behavior. I can open it in the text editor either by double-clicking the behavior or opening it in the editor by using the button. Here, in the Python script, we see that the first lines are used for importing modules. So I recommend to check the Python 3 API documentation, and you can access it from our Help tab. Looks like this. I prefer this overview page, and in this I can see all the modules and also the classes they have. We imported the VC Core module, for example, so I can select the module page and I can see what methods and properties and events it has. Also, we have examples at the bottom of the page. In the script, we have two event handler functions. First is def on signal. If we print the signal and we can compile the script, check before compiling that the simulation is not running. Now, when I run the simulation, I can notice that the sensor triggers prints the signal information to the output. But let's add logic that will stop the pallet, and the def on signal cannot consume any time. So for that reason, let's not use the def on signal, but let's use the def on run. This event handler gets triggered when the simulation starts. So let's write a print hello world. Let's compile, clear the output and start the simulation, and we got the hello world printer. Let's stop the pallet by using these two signal behaviors. Let's wait until they trigger a value. And you can also drag and drop the behavior to the editor. It will save you some typing effort. So let's drag both of them here. Let's initialize the variables. Next, let's write a while through loop, which is a never-ending loop. Let's take the sensor boolean signal behavior, call its waitFor method. That we define that we are waiting for the true value. This will consume simulation time, so before the method call we add await. Then we can add a print pallet at the sensor. Inside the while true loops, when we are testing, it's good to add a delay just in case. So let's write await. Read the delay from the VC core module, so we use VC dot 1 second delay. Compile the script, start the simulation. Interesting. So to the output we got hello world and then we got the pallet at the sensor multiple times. What this means that we got one pallet in, but still the while true loop went through multiple times, as we can see from the prints in the output panel. So what happens is that this line waitFor waits that the sensor is true, then we have a 1 second delay, and then it checks again if the sensor value is true. It never waits that the pallet would actually leave the sensor, which we want, because for each pallet we want that the while true loop goes through only one time. We can add a keyword argument to this waitFor, and we can call it wait trigger true. This means that we are waiting the rising edge from the sensor. We can now reset the simulation, which also compiles the script, clear the output, run the simulation. We notice that we got only one print from the sensor, and now we got the second. Now it works as planned. As a next task, let's stop the product. For that, we need the handle of the pallet component, and we can use the sensor component signal behavior. We can call its value. That will return us the pallet. Variable that we can print to the output. Let's clear some of these old prints. Clear the output, compile the script, run the simulation. As we can see, we got the euro pallet to the output panel. Use that handle to stop movement. Then we have a delay, which we can increase now to 10 seconds. And then we can call pallet stop, no, start movement. We can remove the print. Let's see what happens. Pallet gets stops for 10 seconds. Notice that I'm running the simulation faster than the real time, so it looks less than 10 seconds. But if I would slow the simulation time, it would run and again. Now we can add some smart logic to the script. Let's import the random module. Let's have a 30% chance of having a failed product. So we can write the if statement. We want that this palette material would turn as red in case the failure happens. Let's speed up the simulation. Yes, we got one and the second. So now we have a 30% chance of getting a failed product. Next step, let's add a counter to this sensor that counts how many products have passed the sensor and how many failed products we have. Properties are accessed like dictionaries. Let's also add an additional feature that when we reset the simulation, we want that the counter values will be reset as well. For that, let's use def on reset event handler. Now we got an output print. The issue is that when assigning a value to the property, we need to use the value. Let's reset the simulation, which also compiles the script. Now the smart sensor works as planned. That concludes this exercise. Have a great day and see you in the next one.